Welcome, Rams. I have a really quick joke for you before we begin our properties notes, all right? How does the ocean say hello? It waves. Thought you'd like that today. Okay, so today's homework is over the properties of operations. Okay, and we have several different properties. And what this does, it gives us a set of rules for how to tell if expressions are equivalent. Okay, so first one we'll talk about is the identity property. Now we have two of them. Okay, your identity is who you are. That doesn't change, right? Okay, you are who you are. I am Mrs. Moreau and I will stay Mrs. Moreau. Okay, so my identity doesn't change no matter what I do. Now, we have the identity property of addition and the identity property of multiplication. Now, the addition one says that any number that I have, I could add 0 to it and I keep that same number. It doesn't change it. I do not change the identity of that number by adding 0. I also do not change the identity of a number by multiplying by 1. So, in here it says, adding 0 to a number does not change its value or identity. And multiplying a number by 1 does not change its value or identity. So what we're going to do is just add another example in here, okay? So we're also going to use algebraic examples as well. So I could say 3, was 3 the number on here? Nope, okay. 3 plus 0 is still going to be 3. Or we could use a letter. We could say M plus 0 is still M. Okay, my identity did not change. If I add 0, nothing happens. Okay, now the identity property of multiplication. Multiplying by 1 does not change the value or identity of the number. So 28 times 1 will still be 28. Or I could say A, which any variable, times 1 is still going to be A. Any number that represents any number in the world, I can multiply by 1 and the answer will stay the same. Okay, that is the identity property. We have two of them, one for multiplication and one for addition. Now, the inverse. An inverse means opposite. Okay, the inverse property says if I take two opposites and I add them together, I find the sum, it will always be 0. So these two numbers, I add them together and it gives me 0. The sum of a number and its opposite or inverse is 0. Sum means addition. Okay, so I could say 16 plus negative 16 will give me 0. We call this the inverse property because inverse means opposites. Now, I could put a variable in there. I could say R plus negative R equals 0. That means any letter could represent R. Okay, whatever that letter is and the opposite of it. If I add them together, I'm going to get 0 every time. Okay, commute. If you commute to work, you travel, you move, you drive, okay? So what this means, we have the commutative property of addition or multiplication. Now, it only works for adding and multiplying, not dividing or subtracting. It says I can move the order of these numbers and it doesn't change them. Okay, that this expression is equivalent to this expression. 6 plus 9 is equivalent to 9 plus 6. 5 times 4 is equivalent to 4 times 5. Okay, I can move these numbers. Okay, when adding or multiplying two numbers, changing the order of the numbers does not change the sum or the product. So I could say, what did I use? 3 times 7 is the same as 7 times 3 because they both equal 21. I could say A times B is equivalent to B times A. When we put a variable in here or a letter, what that means is I can put a number in its place. They can be substituted with a number. Okay, for addition, I could say, I don't know, 16 plus 5 is the same as 5 plus 16. Okay, I could also use a variable here and say M plus n is the same as n plus m. Okay, we're just going through some examples here. Now, associative. The associative property, there's a phrase that I used to hear would say, who you associate yourself with defines who you are. So that really means who you group yourself with. So associative property means grouping. So we can write that out here. Okay. Now this means for addition or multiplication, I can group these numbers however I like. So right here, this says I would do 6 plus 1 first and then add it to 8. So 6 plus 1 is 7 plus 8 is 15. Over here, this one says I would do 8 plus 1 first and get 9, and then add 6 to that 9 and get 15. So it's saying that for adding and multiplying only, I can switch the grouping. Just like I could switch the order, I can switch where they're grouped. It does not change the answer. So my definition inside here says, when multiplying or adding more than two numbers, the grouping of the numbers does not change the product. Okay, so I could say 1 plus 2 plus 3 is equivalent to 1 plus 2 plus 3. Okay, it does not matter. Okay, I will use A, B, and C next. A times B times C is the same thing. So if I have A right here times B times C. This works for adding and for multiplying. I can change the order of where I group them, where my parentheses go, as long as it's only all adding or only all multiplying. If there's any other operation in there, I cannot do that. Okay, my distributive property, that's the one we will probably use the most often, and it's the one that most students struggle with. Okay, so to distribute means to share something or to pass it out evenly. If I distribute cupcakes to my class, then I'm going to share them with everyone. So this right here says, if I have this 5 right up against my parentheses, I have to share it with everything inside the parentheses. So I could solve this with 7 plus 4 and get 11 and multiply that by 5 and get 55. That would be the same thing as saying that I could do 5 times 7, and I would add, because this is addition, and then 5 times 4. That's what I did. I shared my 5 with the 7 and with the 4, but it's multiplied. This 5 is multiplied by each thing inside here, each number or value inside the parentheses. Okay, it works right here too. Even if it's subtraction here, I have my 2 times my 9 minus, because this is subtraction, 2 times 5. Okay, we're going to give some examples, and we can also use variables. Okay, it says multiplying a number by a group of numbers added together is the same as doing the multiplication separately. Okay, so I'm going to say 12 times 5 minus 3 is the same as 12 times 5 minus 12 times 3. Okay, if I do this right here, 5 minus 3 is 2. So 12 times 2 is 24. And I can go over here. 12 times 5 is 60 minus 12 times 3 is 36. 60 minus 36 is 24. That these are equivalent. Okay, we'll be using this one a whole lot, okay? I'll give you some examples here. So I'm going to give you letters this time, okay? I'll use A, B, and C. So I have A times B plus C. That's the same thing as multiplying A times B plus A times C. All right, have all of these in your notes when you come back to class tomorrow, and we can glue them onto a piece of paper and put them in your binder again, okay? And we're going to be using these for the rest of this unit, so it's very important that you keep up with it. All right, have a great day.